Hi, this is Miss Reese, and I'm going to be explaining what you still need to do if you have not completed your Unit 8 test or if you need to retake it. So where you find the Unit 8 test, you can find it in two places. Well, directions to get there, sorry. On my calendar page, it was on, I believe, the 25th. Unit 8 test on CUDA. So we have some of the directions here. We have the website to log in. And then also if we go to my calendar page, well, you'll see that here, or on Canvas, I'm on student view. So let's look at the assignments. So in the assignments, I would maybe recommend if you are currently showing your assignments by date, I've taken out a lot of the due dates so that they wouldn't show as red for some of the old things that you're now submitting online that originally were not submitted online. So I recommend showing your assignments for my Canvas course by type. So you have all the practices here, all the classwork, distance learning started, what here? When I started putting the dates in, 317, this is all distance learning. Assignments, we have some quizzes and then your tests. So the Unit 8 test for polygons is here. And I'd like to show you how to sign up for CUDA. So if you've already signed up for CUDA, great. If you have not signed up for a CUDA account, you will want to watch this video. It explains how to do it, some common mistakes that students make when creating their CUDA account. And then you're going to use these codes depending on what class period you're in. So quickly, let me just show you on CUDA. Once you do get there, you might see a few different things. There's, a Unit 8 practice test. I'm going to go over that in this video today to prepare you. You should have a Unit 8 test there and a retake. If you don't, you can always contact me and I will reset that for you. You can see here that I'm in progress of some of these. This is kind of a sample student account. So when I do go into it, I'm resuming here. And I don't know what question this is, so I might want to pull that up on the side and show question progress. Do keep in mind, and I showed this in my video, that once you've submitted an answer to a question, like let's say, for example, this is question 1, I'm submitting my answer, I cannot go back to that question ever again. So if you want to, you can go through all of the questions at once without submitting and then submit at the very end. So that's kind of up to you. Just know that once you do submit for that particular question, you can't go back to that question. Do make sure that you're writing your work down. I think I wrote that here as well. You must write your work on a piece of paper and number each problem. Do you know that you're getting different questions from other students? They're self-generated questions. So the practice test that we're going over is basically the same test, just different numbers. Okay. So some of you might have done the test originally and now you need to retake it because you didn't show your work. So that's exactly where you're going. You can go back here, CUDA Works, and then you see everything that you have in progress to still work on. Okay. So for now, I'm going to go ahead and have us go over the practice test so that you feel prepared to take the test. So let me make this a little bit bigger. You can print this. I'll actually add a link to this on the test page. You can print this from there. And it might be helpful to just number the questions if you don't have a printer and you just want to write it on a piece of paper. Okay. And I would also recommend having your toolkit out for Unit 8. That's where I'm going to pull most of my formulas from. Okay. So we are finding the interior angle sum for each polygon. And here we have a regular 21 gon. So my formula is that the sum equals 180 times the number of sides minus 2. That's our formula. So if a shape has 21 sides, that means I can create 19 triangles in that shape. So really the work that I'm looking for is that you're writing 180 times 21 minus 2, or you wrote out 180 times 19. So that would be 3,420. Question 2, just the same type of question. I'll post the answers for this practice key as well. So if you're doing the even questions, that you can make sure you're getting them right before you take your test. A regular 22 gon, we are finding the measure of one interior angle. So each interior angle is equal to 180 times n minus 2. But then we need to divide by how many sides or how many angles we have. So this on top is giving us the entire degree for that shape, the sum of all the angles, and then we divide by how many sides we have. So in our formula here, we would do 180 times 22 minus 2, and then we're going to divide that by 22. You can create a fraction or you can just put divided by. So we're going to do 180. 22 minus 2 is just 20. And then we're going to divide that by 22 because there's still 22 angles. And we want a decimal format for this. So 163.6. Here we go. Question 5, we are finding the measure of one exterior angle. So our formula for that, each exterior angle. So if you remember, the total sum of the exterior angles is always 360. There's no formula to memorize for that. But if you're looking for each individual angle, then you just have to divide by n, or the number of sides you have. So we've got 360 divided by n. So in this case, it'd be 360 divided by 19. And that would be 18.9 degrees. Okay, now we're looking at some shapes here. We have a triangle. Triangle sum theorem says we have 180 degrees total in our shape. And we know this right angle symbol is 90. So to figure out this question mark, you could just take 180, you could subtract 90, and you could subtract the 50. And that would leave you with 40 degrees. Here we go. This shape here is a quadrilateral 360. Since it's a little bit different, I will go over this question. We could just take 360 then and subtract 102, subtract the other 102, and subtract the 78. This shape just so happens to be a parallelogram. Let me move this over just a little bit. So these opposite angles are equal, so then these opposite angles end up being equal as well. So what we're left with is 78 degrees. Okay, on to the next page. We have now questions where we're using a triangle and a quadrilateral, but we are solving for a variable. So remember, we know a triangle adds up to 180. So what I'm going to do here is I have a 74 degree angle and a 71. So I'm going to take 180 and I'm going to subtract 74, and I'm going to subtract 71. And remember, you need to show your work. So I would write something like 180 minus 74 minus 71, where we got 35 degrees. So that means this angle here needs to equal 35 degrees. So then we would say, okay, well, 7x needs to equal 35. And then if we divide both sides by 7, x is 5. If you wanted to, you could also, set up an equation where you just added all of these to equal 180. You're still going to get the same exact answer. So if you wrote 7x plus 74 plus 71 equals 180, that would work as well. Here we have our quadrilateral. Remember, we have 360 degrees in total for any quadrilateral. So 360. I'm going to subtract these three angles here. So minus 80 minus 100 minus 95. And let's see what that fourth angle is equal to. So 360 minus 80 minus 100 minus 95 is 85. So this angle here has to equal 85 so that all four of these are going to add up to 180. And then we could just say 11x plus 8 equals 85. So subtract 8 on both sides. 11x equals 77, divide by 11, and we get x equals 7. And for this one, you could have also just, you could have added 11x plus 8 plus 80 plus 100 plus 95 to equal it to 180. And that would give you the same result as well. So that's it for angle measures and shapes. Now we're moving into the area portion of the test. So remember, for triangles, we have two different formulas. So one formula that we're going to use for this problem is base times height divided by 2. And something that you need to keep in mind is that the base needs to be perpendicular to the height. So you need to have some type of right angle symbol in that shape. Okay, so for this shape here, I have a right angle symbol. So that means this side 3 and this side 1.3 are going to be the base and height. And that 2 and 2 is just kind of extra added information to make sure you know which sides would be considered the base and the height. So for the area, we would just plug it into our formula. We get 3 multiplied with 1.3, all divided by 2. 3 times 1.3, let's see what that equals, divided by 2. That's our area. This question is different method. So we don't have a base and height because we don't have any right angle symbols showing anywhere. So we call this the SAS method for the area of a triangle. So that means you have 2 sides of a triangle and you know the angle between them. So what we do is we multiply the 2 sides, 5 multiplied with 6, multiplied with the sine of the angle in between them, and that's all divided by 2. And this should be in your toolkit for this as well. So we say the formula, if you want the actual, write down the formula, S1, side 1, S2, another side of the triangle, and then the sine of the angle in between them, all divided by 2. So that's the actual formula. Now we're just plugging it into the formula. So from here, depending on what type of calculator you have, I'm just going to create a fraction here where we can do 5 times 6 times sine of 153. We're going to divide that by 2, so it's going to be 6.8 if we're rounding it to the 10th place. Okay. Question 13 and 14 are pretty similar, so I'll just go over 13. Now these are both regular polygons, meaning all their sides are the same, so 15, 15, etc. So here we have a 15, and what I'm going to focus on is this triangle here. So I know this length is 13. It's highlighted on the triangle. It's drawn in for you. This length here is 15. So if I want to find the area of this triangle, I would do 15 multiplied with 13 divided by 2. But I want the area of the entire shape. So this was the base, this was the height, and this is a 1, 2, 3, 4, 5, 6-sided shape. So this is the number of triangles. So essentially when you're finding the area of a regular polygon, you're going to use the side angle side method, or you're going to use base times height divided by 2 method, but you just need to make sure you multiply it by however many triangles you have. So it might be helpful for you to highlight that triangle and then just see, okay, is that one of those triangles per side, or are there 2 of those triangles per side? So this was 1 triangle per side, and there's 6 sides. So now plugging that into our formula, we would get 15 times 13 times 6, all divided by 2. And that would be 585. So you're going to use the same method for question 14. We've got the base and height of a triangle, and we've got 8 sides, or we would call it 8 triangles. Question 15. I'm going to actually do this in a little simpler of a format, and then I'm going to show you how you can change your answers from decimals to radical form, or how you can compare them. So this length is 11. That's a radius of the circle, or of the shape. This is also going to be 11. And then if I wanted this little angle in the middle between that, well, I would say, okay, well, the full rotation around this is 360. If I take 360 and divide it by 6, that's going to give me 60 degrees. Okay, so we have 60 here. So I can use the side angle side method for this. So we've got 11, which is one side, times 11, which is another side. So these are both 11s, times the sine of the angle between them, all divided by 2. Now that's the area for that one triangle. And this is a hexagon, so there are 6 of those triangles. Now let's check in your calculator. Most of your calculators will probably give a decimal answer. So 11 times 11 times sine 60, all divided by 2. Oops, and I forgot to multiply by 6. There we go. So my solution for this is 314.367, we'll say, and that's an approximation. And I can't on this calculator turn a decimal back into a radical form. So what you're going to need to do is 96 square root 3. Let's see what that approximation is. Okay, it's not the same. Let's move on to 900 square root 3. Okay, not the same. Let's move on to 363, square root of 3 all over 2. And we've got a match. There we go. And you could check the last one too if you needed to. Okay. Our next question, I'll show